topic we have gone through, right? That was how to draw the resultant force from fewer forces when we were having some forces in different directions. Okay, is it clear?
Yes, sir.
Okay, right. So today we will discuss about Newton's laws, Newton's first law, second law, and third law, and then we will practice some of the questions, right? So let's talk about Newton's laws. Okay, so Newton's laws, actually, when we talk about force, and if we do not talk about Newton, it would not be justice with him. That's why Newton's laws, there are three laws. Then let's talk about first law. Newton's first law is called law of inertia also. Okay, we call it law of inertia, and this law is valid under the balanced forces, right? How does it work? It works under balanced forces. So if I say that this law is valid when net force equals to zero, then it would not be wrong. Net force means resultant force, right? What is net force? Net force is basically your resultant force. When the resultant force is equal to zero, then this law is valid. Now, what is this law? If I'm going to tell you about this law a lot, then this law states that a body at rest are moving with uniform velocity. So a body will remain at rest, will remain at rest, or will move with uniform velocity until unless a resultant force acts upon it. Right? Until unless a resultant force acts upon it. So it is basically in the absence of a resultant force. Until unless a resultant force acts upon it. Okay. So simply speaking, when a resultant force will act on a body, it will change the motion of the body. What will happen? If there is a resultant force, that resultant force will change the direction of motion of the body. So I can say that a resultant force will cause acceleration. What will happen when a resultant force will be applied? A resultant force will cause an acceleration. Okay, that will cause an acceleration. So what is inertia then? Are you aware of inertia?
Yes.
Inertia is basically the same thing. Inertia is the property of a body due to which it resists some changes. Okay, this is basically the property of a mass due to which what happens, due to which it opposes the or due to which it resists the change. What does happen? It opposes or it resists the change in its pre-existing state. In its pre-existing state. What is its pre-existing state? For example, a body is at rest, then it would remain at rest. If a body is in motion, it would remain in motion. So this is the same thing as the first law states. That's why the first law is called law of inertia. Okay, is this clear?
Yes, sir.
So as I told you, that first law will be valid when there would be no force, no resultant force acting on the body. So, for example, this body is under the influence of several forces. Suppose 10 Newton from this side, then you can say 20 Newton on that side and 20 Newton on that side. So, this body is basically under first law. This is under balanced forces. Okay, that is under balanced forces. Got it? Now let's talk about second law. Okay. Second law tells us that when there will be a resultant force, there will be an acceleration in the body. As I stated earlier, the resultant force causes an acceleration. Okay?
Okay.
Resultant force, resultant force causes an acceleration in the body, causes an acceleration in the body. Okay? So that acceleration, this is not the part of second law, but here the acceleration will be directly proportional to the acceleration which is produced is directly proportional to mass of the, sorry, force applied, directly proportional to, directly proportional to force, I mean resultant force. Okay, and inversely
Okay.
proportional to mass of the body, and inversely proportional to mass of the body. Got it?
Yes.
Inversely proportional to mass of body. Now, this is very simple in our daily life. If you are going to give more race to your car, if you have more engine power, your car will accelerate more. But if you load it more, what will happen? This car or that body will accelerate less. So, mathematically, I can say that mathematically, how can I make an equation? Mathematically, this acceleration is directly proportional to force and acceleration is inversely proportional to mass of the body. And if we reframe these all, we can say that acceleration is equals to force divided by mass. So this helps us, or this leads us to F equals to ma. Where does it lead us? F is equals to ma. This is very famous equation. I think E is equals to mc square is famous by Einstein, and uh, this F is equals to ma is much more famous equation for Newton, right? So what is important in this equation? Important in this equation is F. So F is basically, this is your F net. F net is equals to, remember this thing, driving forces, F driving minus F resistive. I'm going to write this equation for you. It will work all over the physics, not only in IGCSE. It would work till your mean any level of the physics. So whenever you are going to find out the net force, this force is applied over there. Which force is applied over there? This force, F net. So it means that your formula will be F driving minus F resistive. This is the net force, that is equals to ma. This formula will work all the times. Okay.
Okay.
So I can say that, for example, let's have fewer examples and then we will move forward. Let's say I have a truck or a block. Its mass is suppose 50 kg. Okay, and I'm going to apply a force of 10 Newton over here. Then how much acceleration could be produced by this force? The acceleration will be equals to 10 divided by 50, which is equals to 0.5 meter per second square. Is it?
Yes.
But now, if I apply the force of, let's say, 20 Newton on this block, then acceleration would be 20 by 50. It would be 20 by 50 equal to how, 0.04.
Yeah.
Oh, sorry. It is 0.5. No, it is 0.2 meter per second, right? And this is 0.4 meter per second square. So I have doubled the force, so acceleration has been doubled. But now, if I say that the mass is same 50 kg, but the forces are, let's say this is your 13, or let's say this is your 15 newton force, then what will be the acceleration?
So, like,
1 meter per second square, right?
yes.
Right. Now let's change the situation. The same block is under the observation, and on that block your one force is 50 newton, and now there is other guy who wants to apply an opposite force. Let's say that force is of 20 newton in this direction. Then what would be the acceleration in this block? Now this is the driving force, this is your driving force, and this is your resistive force. Got it?
Yes.
So we can say that acceleration is equals to 50 minus 20 divided by mass. Okay? Or if you want to change these values, to change all these numbers, then this can be 60, this can be 20, this can be 50. So what will be the answer? 40 divided by 60, and 40 divided by 60 is basically 2 by 3. So 2 by 3 is 0.66, right, meter per second square. So this is that acceleration. But when you are going to increase the mass of the same body under the same conditions, now I have filled with this. This block is of 100 kg. How much mass does it have? 100 kg. The forces are same. This is 60 newton force, and this is 20 newton force. So what would be the acceleration in this case? The acceleration would be 60 minus 20 divided by 100, so it would become 0.4 meter per second square. Now is it clear to you?
Yes, sir.
Right. So actually, when we are having this situation of the block masses and all that stuff, we have to consider it. Okay, am I right?
Yes.
Okay, now after that we will talk about Newton's third law. Okay,
Yes.
Newton's third law states that when there would be an action, there would be a reaction of that, right? And that reaction would be equal and opposite to that action. So first I will write a phrase that when there will be an action, there would be a reaction. So you can simply say that every action has equal and opposite reaction. Every action has, every action force, action mean action force, has equal and opposite reaction force. Equal and opposite reaction force. Got it?
Yes,
Okay.
sir.
So remember this thing. This is very important thing. Every action has equal and opposite reaction. So for example, F1 is your action force and F2 is your reaction force. Then both forces are equal but opposite in direction. So this negative sign shows that opposite in direction, right? Opposition in direction. Now problem is when you are having this situation, action and reaction are on two different bodies. Remember this thing. Action and reaction are on two different bodies. This is very common misconception. Action and reaction are always at two different bodies. Okay, at
Right.
two different bodies. Okay, how? I will set an example. Let's say I have a block, I have a table, and on that table, I have placed a book, Okay,
Okay.
this book is actually having weight downward. Okay, this is weight of the book, weight of book. Now, this is an action force. What is this? This is an action force. So, what is basically reaction force? Usually, people say that this is the reaction force, but no, it is normal reaction force. Normal reaction force, or you can say simply normal force, right? Let me explain in different ways in next on next page. Now same book is placed on the horizon of the earth. Let's say this is the horizon of the earth, and you are going to place a table over there this way, right? And now that book is placed on the table. Okay, what do you say? This earth is pulling this down, is it?
Yes.
So this force is called the weight force. I will talk about that weight force as well. Now, this book would attract the earth towards it this way. Now, I would complete the earth's diagram. So what will happen if you check this one out? This is earth. So if I say that the book is basically pulling earth towards it, right? So this green one is, let me rewrite this all. This weight is pull of pull of earth at book. Got it? And
Yes.
this is your action force. This is your action force. As a reaction, earth pulls this, sorry, book pulls this earth towards itself. This is pull of book at earth, and this is basically your reaction force. Is it clear?
Yes.
So don't get this misconfusion or misconception that action and reaction are basically different. Action and reaction are very simple over here. In this case, your normal reaction force or normal force, this is that force which is exerted by table on the book, right? This is the force of table at book. It is a reaction of downward pressing, right? It is a reaction of downward press, downward pressing force. I can name this as pressing force, although it is not a pressing force. But now there is a student and he wants to apply some force. He place hand on that book, okay, and he presses the book downward. Does he increase the weight of the book?
No.
No. But what what will this table do then?
It will.
You are going to press the book downward. So what would be the black force? Which one? Will it be increased?
Yes.
What about the blue one?
No.
And what about green one?
Also no. They are
Yes.
gravitation.
They are not changed. Exactly. So if this black one is reaction of pull of earth, then definitely it would change. But because pull of earth is not changed yet, that's why by applying your hand on your book, you are just pressing. So table has to apply more force. That's it. Is this clear now?
Yes, sir.
Okay. So this was basically about your action and reaction. There are so many examples of that. You can have a lot of examples, right? And those examples are actually when we walk on the earth, walking, running, climbing, right? There are so many things. Okay, writing, etc. They all includes this action and reaction. Is it clear?
Yes, sir.
Okay. Now let's talk about some types of forces. Types of forces. There are few types of forces what I want to explain at the first, but because that was not a big topic to be explained, right? It is just to tell you about forces. So here I have I got a presentation, and there um, fewer forces are being discussed. Okay, I would see that maybe some forces are shown over there. So quickly we will go through them, and it would be easy then to handle all of these forces. Okay, now yes, here are some forces. These are the forces. Yes, weight is action, and this is set as reaction. So I told you that although this is reaction, but this reaction is pull on the earth. Okay, so be careful about that. Then secondly, this is the tension force. Tension force creates when an object is hung downward. Okay, when an object is hung downward, then it creates a tension. So tension does not have any direct calculation. Then when an aircraft is uh, under consideration, there are some forces. One is upthrust, sorry, one is thrust of the engine, one is upthrust. I will talk about this in detail. Then drag, I will talk about this. And weight, you people are known with weight when I was at the topic of mass, weight, and density. Okay.
Okay.
Okay, then here, when you are going to have pushing force pushing downward, then there is a friction which opposes the motion. Then this is weight, and then there is a normal reaction force. So these are some of the forces. So uh, when an object is under balanced condition, this is a pulling force, it will cause a tension on this rope. Then this is a normal reaction force, then there is a friction force, then there is a weight. So all of these forces would cause a reaction. In the same way, here, Formula 1 racing car, it has different forces acting upon. So I think so that you are now known with rest of the forces, that how to handle these forces. Right now, let's talk about the force. I mean, the forces what I was talking about. Here, I will just name those forces. First, it was weight force. Okay, then it was weight was due to gravity. Okay, then tension force. Okay, tension is basically due to stretch or weight. When you are going to hang an object, then tension is caused. Then there was a force which was to be discussed, that is upthrust. Okay, we have to discuss this upthrust in detail. Upthrust is basically that force which is caused when an object is immersed in a liquid. When any object or any mass is submerged in the water, object is submerged or immersed in the water, immersed in liquid, rather water, then it experiences a buoyant force, or a force which is which tries to keep this body floating. Right, this is basically the supporting force from nature, which keeps the or which tries to keep the body floating. It does not get successful all the times, which tries to keep the body floating. Okay, Now,
Okay.
when we have this force is, what is the origin of this force then? It is due to, it is due to density of liquid, okay. Secondly, volume of the object. These are two main factors. Volume of object, what object is being immersed, its volume. And third is basically gravitational pull, okay, gravitational pull. So these are three factors upon which this upthrust depends. So I can say that upthrust is equals to rho g into v. This is formula for your upthrust, okay. Here I have concept of pressure of the liquids, but as I'm not in the topic of pressure, that's why I will not be getting involved in that. But simply you have to memorize this equation, okay, that this is rho g h is equals rho g v is equals to upthrust. And it's not the game of complication, because you now that pressure due to liquids is, you know what is the pressure due to liquid? That is equals to rho g h. Is it? Do you remember this equation?
Yes.
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 So if I have an object immersed in the liquid, and that object is having some force on it, its base area, then I can simply say that weight of this liquid column, this is the liquid of density rho, and its weight is acting on this area, base area, this one. Then definitely you now this thing from the concept of pressure, that pressure is equals to force divided by area. And because force is weight force acting on area, so it would be simply that weight which is acting at this surface. Got it?
Yes, sir.
So I say that weight is equals to mg divided by area, and you know that, mm, because it has density rho, and if I say that density is equal to mass divided by volume, so your mass is equals to density into volume. So I can replace this equation over here. That equation would become that pressure is equals to, I will replace this value for the mass. It is rho into volume into G divided by A. Got it? Is it clear?
Yes, sir.
So it is basically rho. What is the volume? Volume is actually base area times height of this object. Okay, base area times height of this object. So I can say area into height into value of g divided by a. So this a and a would be gone. So you got this equation back. That is pressure is equals to rho g h. So meanwhile, moving quickly, I had I have cleared you this topic of rho gh as well. If you have any question to ask, you can ask me right over here. So this is that equation which basically refers pressure of the liquids. So here I would write a comment that pressure of the liquid only depends upon, what happens to the pressure. Pressure of liquid only depends upon depth of the pressure, density of the pressure, not area. Pressure of liquids only depends, okay, only depends upon density and depth of liquid. Depth of liquid, not its area, not its area. Remember this thing. So this is basically, mm, this was a linked topic with upthrust. That's why I talked this. I discussed this upthrust over here. Here, when I will talk about the variables involved in upthrust, the variables are upthrust is equals to rho g and v. So Rho is, what is rho? Density of the liquid. What is G? Gravitational field strength. And V, which is the volume which is immersed inside the liquid. So density of the liquid, density of liquid. Rho is gravitational acceleration. Got it? Gravitational acceleration. And V is volume of volume of liquids. Okay. No, sorry, volume of object immersed. Sorry, volume of object immersed. So this is basically the main concept of upthrust. When we will discuss about the questions, it would be very clear to you. Now, quickly, I will go to the topic of friction and drag. Actually, friction is the force which opposes the motion. What is friction? The force which opposes the motion. Okay, the force which opposes the motion. Got it? Is it clear to all, both of you? Hassan, did you join?
No, he
No.
didn't.
Oh my God, where is he? I thought that he had joined. Anyhow, okay, which opposes the motion. Now I can say that friction appears in two ways. In fluids mean air, gases, water, or any liquid. The friction is named as drag force. Okay, friction is named as drag force. What do we call it? Drag or viscous drag. Okay, so that drag force or viscous drag is basically, uh, the important thing for that is that viscous drag or drag force increases with speed, increases with speed of the body. So as you have opened the hand, or put your hand out of the window of a car, as the car moves up or as the speed of the car increases, what happens to your speed, to the drag force, or what happens to the opposition? It increases now.
Yes.
Yes. So this was basically an overview of your forces. So is there any confusion in that?
No.
Sure.